I will.
All right, so I'm going to go on and talk about equivalent fractions. And I wrote this down so that you could see it, because sometimes there it is, I speak quickly. And it says that what equivalent fractions are is that they are fractions that represent the same value, the same part of the whole, but they have different numerators and denominators. So here's an example. So 1/3 is equivalent to 2/6, which is equivalent to 4/12, which is equivalent to 8/24. Okay, those are equivalent fractions. They actually name the same value, but the numerators and the denominators are different. And the reason that we want to be able to create equivalent fractions, be able to reduce them or raise them, is that when you add and subtract fractions, you have to have common denominators. Not a problem with multiplication and division of fractions, but it is when you add and subtract, and it's also important when you compare fractions. You can't compare them unless they have the same denominator. So, and Taisha, stop me, turn on your microphone anytime if there's a question that you have, and I'm happy to try to answer it. So what I wanted to show now is a little video that I found online that talks about understanding equivalent fractions. It's about 5 minutes long, and I think it's a really clear way to get a sense of how you make equivalent fractions and why the method we use actually works and why it's a good way to do it. So let me try to share my screen, which I didn't do there. Let's try this again. Let me try to, oh, no. Okay, I'm going to share my screen, and I am going to show this little video in a minute. Where did the video go? There it is. Okay, so equivalent fractions. I'm going to start the sound. I think you should be able to hear it. I practiced it last night, and the person that was listening in was able to hear it. But again, if you can't hear it, Talisha, unmute your microphone and let me know. So here we go.
Equivalent fractions. Here is 1/2 pi. And here is 1/2 of the pi. Here are 2/4 of the pi. Here are 4/8 of the pi. These fractions show the same share of the pi. This means these fractions are equal or equivalent. Notice how the numerator and the denominator of the fraction both increase by a factor of 2. You can find equivalent fractions by multiplying both the numerator and the denominator by the same number. You can also find equivalent fractions by dividing both the numerator and the denominator by the same number. Let's learn more about equivalent fractions by looking at more examples. Are these two fractions equivalent? Yes, because there is a number that both the numerator and the denominator can be multiplied by to get to the equivalent fraction. What about these two? Are they equivalent fraction? Yes, there is a number that both the numerator and the denominator can be divided by to get to the equivalent fractions. How about these two fractions? Are they equivalent? They are not equivalent. There is no number that both the numerator and the denominator can be multiplied or divided by to get to the other fraction. One last example with these two fractions. They are equivalent because there is a number that both the numerator and the denominator can be multiplied by to get the equivalent fraction. We have now seen how to find equivalent fractions. Let's finish the lesson by seeing why we have really just been multiplying and dividing by 1. We have found equivalent fractions by multiplying or dividing the top and bottom by the same number. This is the same as multiplying or dividing the fraction by another fraction that has an equal numerator and denominator. Any fraction that has the same numerator and denominator is equal to 1. Anything multiplied or divided by 1 does not change. This is why multiplying or dividing a fraction by another fraction that has the same numerator and denominator results in an equivalent fraction. Finding equivalent fractions is very useful when we are looking for common denominators to help with adding, subtracting, and comparing fractions. The other lessons in this series are...
Okay, so I'm going to come back to our meeting. Okay, Tylisha, you can unmute if you'd like. Did that make sense to you? Okay.
Yes. Yes, that made very, very much sense to me. The thing that I get confused about is I think I probably need to kind of study the definitions of knowing like the a common denominator versus a greater common denominator, or because I know it's more than one area with the fractions. Like they have like the least common denominator, the greatest common denominator,
Right.
or is that something different?
No, you're right. That comes into play with trying to decide if you've simplified the fraction. Okay, so let's take a look at a couple of them and see if we can discuss that. Okay.
Okay.
Okay. So let me put one up here and let's take a look at this sort of simple example. So here we have 1/3, and we're trying to make it into a fraction that has a denominator of 6. Okay? So when you raise fractions, it's sort of easy in the sense that you can raise it as great as you want. Okay? So for instance, in this case, can you see how you would get from 3 to 6? What you would be multiplying by? So in other words, you would be saying to yourself, 1/3 times something equals something over 6. So,
okay, it would be 2
right,
times 2.
right. So you would then go, I know that 3 times 2 is 6, so your numerator has to be 2, right? And then it would be 2 6.
Okay.
All right.
Okay.
So that's a pretty easy one to do. You can raise 1/3. I'm just going to turn it this way to get it this way. In many different ways, right? So if I want a denominator of 24, okay, in a problem, then I just rethink it and go 3 times what is going to be 24?
It would be 8.
Right, exactly. And the top would be 8 as well. So it would be 8/24. Okay? So I think what you've been talking about is something called least common multiple and greatest common factor. Does that look familiar to you?
Yes.
Okay, least common multiple. Okay, so the reason that we concern ourselves with that when we are making a new fraction is to be able to have the fraction in the simplest terms that we need it for the problem. Because in life, you're not going to be asked, okay, Tylisha, I want to know an equivalent fraction to 1/3. I mean, that's not the way it works. What it would be is, if I have a third of a cup of flour and I want to triple the recipe, you know, what is that third going to be? Or, you know, if you have a third and I have a fifth and he has 2 sevenths, who has the greatest amount? That's when you have to figure out an equivalent fraction, okay? So multiples, let me get a blank piece of paper if we want to go this way with it. Let me get this up here so we can see. So we're talking about least common multiple now, okay? So multiples are like when you skip count a number. So 3 would be 3, 6, 9, 12, 15, and so on, right?
Okay.
Okay. And if I was talking, so we're talking about 3 there. And if I was talking about 4, it would be 4, 8, 12, 16, 20. Okay. So when you want to know the least common multiple, if you look at the 3s and you look at the 4s, which is a multiple that is the smallest multiple that's up here?
12.
Exactly. That's the least common multiple. Okay. So if I had a fraction that was 1/3 and I had a fraction that was 2/4, okay, and I wanted to turn, I'm trying to keep this so you can see it. And I wanted to turn these fractions into equivalent fractions, okay, then I want to know what is the least common multiple, because I don't want to turn them into this huge number if I don't have to. The common denominator that is the smallest one that I can come up with is that least common multiple. So I can turn something 1/3 into something over 12, and I can turn 2/4 into something over 12. Look, see it? So
Yes.
I can multiply 1/3 times something, and I can do 2/4 times something. So to get from 3 to 12, I'm going to multiply by what?
4.
Right. So my numerator is going to be 4 also. So 1 times 4 is 4/12. And the equivalent fraction to 2/4, how do I get from 4 to 12? By multiplying by what?
3.
Okay. 2 times 3 is 6. 6/12. Okay. So
And
least,
those fractions are equivalent. And
yes.
those fractions are okay.
So if my problem said, you know, what is 1/3 plus 2/4? So let me turn this here. Okay. What is 1/3 plus 2/4? What I did was turn this into equivalent fractions. So 1/3 we decided was equivalent to 4/12. Okay. And we said that 2/4 was equivalent to 6/12. 6/12, sorry, 6/12. So the answer is 10/12. Okay. Now,
Okay.
here's
Okay.
where we get into the greatest common factor. Okay. So what we did over here is we raised the fractions, correct? We gave them a bigger name. 1/3 became, 4/12, and 2/4 became 6/12, right? Okay.
Yes.
And we use least common multiple to figure that out. Now what happens is we have 10/12. We added 4/12 and 6/12, and we got 10/12. Now, almost always, when you're solving problems with fractions, and particularly when you take the test, I'll tell you, they're always going to say simplest form, okay? Lowest terms. So if you leave this as 10/12 and you could reduce this fraction, you're probably going to get it wrong, okay? So greatest common factor comes in with this. So let me get a new piece of paper.
Wait, could you go back? I didn't understand what you said when you said before you said get it wrong. I heard simplest form, and then after that, I was lost.
Okay, okay. So we got an answer, didn't we? We got an answer of 10/12. Okay? And were this a problem on, an assessment of some sort, and you're dealing with fractions, almost always the direction is solve the problem and then put your answer in lowest terms, or sometimes it's called simplest form, lowest terms. Okay? Lowest terms means you want to rename your fraction into an equivalent fraction of smaller numerator and denominator. Okay? Does that make sense so far?
Yes, ma'am.
Okay, so let's do that. Okay, let me get a new piece of paper and let me show you what we're going to do. Okay. Okay. So this is where we're talking about greatest common factors. So we had 10/12. Okay. Now, 10/12 is not the smallest name for this value because I can divide both the numerator and the denominator by the same number and get lowest terms. This is where we talk about greatest common factor. Okay, so I'm going to turn this for a minute and I'm going to make the greatest common factors of 10 and 12. And greatest common factor means what are the numbers that I can multiply together to get the number. So, and this is the way I usually lay it out so that I know that I've hit everything. That's a 10 there, okay? I know any number can be multiplied by 1, all right? So 1, and I'm going to put it out here, 1 times 10 is 10. Then I think to myself, what about 2? Is 2 a factor of 10? And yes, it is. 2 times 5 is a factor of 10, okay? Then I say to myself, 3. 3 times nothing will equal 10. 4 times nothing will equal 10. And then I'm back at the 5 again. So I'm going to stop. There's nothing else that I can multiply that's going to equal 10. So I'm going to stop for a second. Talisha, does that make sense how I found the factors?
Yes, that makes sense.
Okay, so let's do the same thing now with 12, okay? I know 1 times 12. I know 2 times 6. I know 3 times 4. And then I'm at the 4, okay? So once I've hit that number, I'm done. All right, so now, let me hold it so you can see it. I have the factors of both 10 and 12 that came from our fraction 10/12. Okay, following so far? It's a little crazy, but does it make sense?
Yes, it makes sense.
Okay, all right. So this, I'm working backwards here. I feel like I'm in a mirror. Okay, so now we have the factors of 10. This, now we are talking about the greatest common factor. So looking at this, what is the greatest common factor of both 10 and 12?
2.
Exactly. Okay, so now I know that to get to the lowest form of 10/12, I can divide by 2. So that's what I'm going to do now. Okay, 10 divided by 2 is 5. 12 divided by 2 is 6. There is not another number that I can divide into 5, 6 that will give me lower terms. And I know that because I found the greatest common factor. Okay, so I'm going to stop for a second. Tell me how we're doing here and whether this is making sense.
I think that it makes great sense, and I understand, and I can do this. I can do this because I understand it, and I'm not confused,
Okay.
and I understand.
Okay, so I'm going to show you something. I'm going to put it up there that is helpful, I think, with finding, trying to decide what you can divide. You can always do the concept of least common multiples and greatest common factors, but sometimes you get a really big number and finding out what's the greatest common factor is difficult. So let me show you another thing that I had written down, which is called rules of divisibility. Let me find that in my stack of stuff here. Let me find it. Hold on. Okay, and I'm hoping that you're going to be able to see this. I'll hold it up. Okay, so this is a chart of rules of divisibility. Okay, this helps us know at least where we can start to reduce the factor. So I'm not sure if you can see it. I'll read it to you also. It says, look at the digit in the ones place. If the last digit is even, in other words, 2, 4, 6, or 8, you can divide by 2. If the last digit is a 5 or a 0, you can divide by 5. If the last digit is a 0, you can divide by 10. Okay? Then there's another divisibility rule that has to do with the sum of a number. And it says the sum of the digits is divisible by 3. So if you can add up the digits of a number, and that number that you get, that sum, that total is divisible by 3, that whole number can be divisible by 3. Same thing is for 6, if the number that you get when you add up the digits is divisible by both 2 and 3, then that number can be divided by 6. Sum of digits is divisible by 9. Again, if it adds up and that answer is divisible by 9, then you can divide that number by 9. And then this is a little bit more confusing, and maybe you don't need to think about this, but if the last 2 digits form a number divisible by 4, you can divide the whole number by 4. And if the last 3 digits form a number divisible by 8, you can divide the whole number by 8. So again, this is sometimes helpful if you were trying to figure out in a fraction that has relatively large numbers, what you can start with. So for instance, let me give an example. Stop me first, so Tylisha, does this make sense, or can I give better examples of these things?
No, that makes sense.
Okay, so I'm happy for you to copy it down, or you can, I'm sure if you just go on the internet, you can ask for divisibility rules and it'll give you a listing similar to this. But maybe would you like to take a look at a fraction and see how to apply this? Would that be helpful? Tylisha, would that be helpful to try to apply this?
Yes, that would be helpful.
Okay, all right, let me put up another piece of paper here. I might have
Okay.
to run out for a second and get some more paper, not to the store,
Okay.
but to the other room, but let me see what I've got here. Okay, so let's say, let me make this one up, okay? Say we have a number that is, okay, 153. Okay, 153 over 8. I want to reduce the fraction. Okay, so the greatest common factor is going to be difficult to do with these numbers. I don't know about you, but I can know that 1 times 153 are factors, but I'm not so far, beyond that. But I can try to bring this down a little bit farther. So if I use my divisibility rules, first of all, this does not end in a 0 or a 5. So I know these numbers are not both going to be divisible by 5. Doesn't end in a 0, not going to be divisible by 10. Doesn't end in even numbers. 3 and 1 are odd numbers, so I can't divide by 2. So now I'm going to try to do some of those sums, and I'm going to add up the digits in the numerator. So 1 plus 5 is 6, plus 3 is 9. And one of the rules that we have is that if the sum of the digits is divisible by 9, the whole number is divisible by 9. Okay? So now let me look at my bottom number.
That's cool.
Yeah, it is. That's a good trick. Okay, so 8 plus 1 is 9. 0 obviously doesn't count. So now I know that both of these numbers are divisible by 9. Now, I'm not sure that that will get me to lowest terms, but it's a good start, okay? So let's do it, okay? Let's divide 9 into 153, okay? So 9 goes into 15 once. 1 times 9 is 9. Subtract, that's 6. 63. How many times does 9 go into 63?
7.
Okay, so now I have a numerator of 17, right? Okay, now I'm going to do 9 into 801. Okay, so, whoops, there it is. 9 goes into 80. How many times would 9 go into 80?
9 times 9 is 81. So 9 times 8 times.
Right. Yep, 8 times 9, 72. I subtract. So I've got 89. Okay?
Okay.
Now, I still don't have really small numbers, but
Right.
I can look at the 17, okay? And I know, looking at greatest common factors, okay, for 17, I know that 1 times 17 is 17. 2 times nothing, 3 times nothing, 4 times nothing, 5 times nothing, 6 times nothing, 7 times nothing. I can keep going. The only things that divide into 17 are 1 and 17. So now my question is, would 17 go into 89? So do you think that 17 would go into 89 evenly?
No.
Okay, and we could try it. I mean, we could pick a number. So for instance, I could say, okay, I'm going to see if 5 times 17, what that gives me. Okay, and 5 times 17 is 85. Well, that's not going to work then, okay? Because I can't do 6 times 17 and get 89, and 5 times 17 isn't 89. So now we are in the simplest form of that fraction. Okay?
Okay.
So what we did, Taisha, is we used both the divisibility rules greatest common factor to simplify that fraction. Okay?
Okay.
So I think that, for reducing and raising fractions, again, raising fractions is a lot easier because you just have to, figure out what you're going to multiply by. Okay? So the bigger issue I think is reducing, but we can do a couple examples with least common multiple, and we can do some with greatest common factor and divisibility. So why don't we try to get in the time that's remaining a couple examples and work those through? Okay, would that make sense?
Yes, ma'am. Yes.
Okay, all right. So let me get another example up here. All right, so we're going to do least common multiple. So let me come up with a couple of fractions, a couple of, let's see. How about if we do 2 6 plus 1/5, okay? All right, so what we need to do in this in this problem, is to come up with a common denominator. And so we are going to use the concept of least common multiple to help us come up with that. So I'm going to take the first denominator, 6, and I'm going to come up with the multiples, okay? So I know 1 times 6, I know 2 times 3, and that's it. Those are the only multiples of, I'm sorry. Whoops! I'm giving you greatest common factor. Let's do multiples of 6. Sorry about that. Okay, 6. So I have 6, 12, 18, 24, 30, 36. Sorry about that. I just had a little brain freeze there. Okay.
No, you're okay. I get confused though. That's why I asked.
Okay. Multiples are counting in sequence, okay? All right. Then let's do the multiples of 5. So I have 5, 10, 15, 20, 25, 30, 35. Okay. What is the least common multiple of 5 and 6 when you look at this? Okay, the least common multiple is going to be...
It's going to be 30. Oh, 30, right. I don't know why I was looking for 35.
Right.
That would be if it was 7 and 5.
Right, exactly. So now what we know is that we can turn 2 6 and 1/5 into fractions whose denominator is 30. So I'm going to do my 2 6 times something. It's going to be something over 30. And something again over 30. Okay? So 6
Okay.
30. 6 times
5.
Good. So my numerator is going to be 5 also. So 2 times 5 is 10. And to get from 5
6.
to 30, good. So my numerator is going to be 6. So now my new problem, I'll put it up here so maybe we can see it more clearly, is 10 30ths plus 6 30ths equals
16 over 30.
good. Okay, now let's take that, whoop, there it is, the 16 30ths, and let's make sure that we have that in lowest terms. So now we're going to think about greatest common factor. We're going to think about to take that 16 30ths over here. Okay. So I can do greatest common factor. So I'm going to start with divisibility rules first. And I'm going to think to myself, I know that 6 is an even number and 0 is an even number. So I know that I can divide both of those numbers by 2. And I'm going to see what that does, if it makes it small enough, or at least it makes it smaller that I can do greatest common factor more easily. So 16 divided by 2 is 8. And 30 divided by 2 is 15. Okay, so I have 8/15. So now I have to think to myself, is that lowest terms? So I know, and I'm going to do this. I'm going to do my greatest common factors. I'm going to do my factors of 8. So it's 1 times 8, 2 times 4, and that's it, right? And the greatest common factors of 15 are 1 times 15, 3 times 5. Okay, so do I have, what is my greatest common factor for 8 and 15?
It's just 1.
Right. And does it make sense to try to divide by 1?
No, because you're going to get the same answer.
So 8/15 is lowest terms, is the simplified fraction. Okay? So, all right, let's do another one. And if you want, Taisha, I'll ask the question. I won't do anything, and I'll wait for you to give me the next answer. Does that, you want to try it that way?
Yes.
Okay, let me get another piece of paper. Let me think of another fraction thing here. Let's see. Okay. All right, so let's try 4/9 plus, what the heck, 3/5. Okay? 4/9 plus 3/5. Okay, so I'm not going to do anything. Okay, so I want you to figure out what's the first thing that we have to do here.
Okay. The first thing you have to do is you will have to find the least common multiple of 9 and 5.
Good.
And then you would make, and then once you find that, you would make that the denominator of both fractions. So it would be 4/49 and, well, 4/45 because it's 45, and then 3/45. And then after that, you would,
Okay, hold on.
Okay.
Alicia, okay, I'm going to agree with you, okay, that let's just do it, okay? Let's play it out. So 9 is 9, 18, 27, 36, 45, and 5 is 5, 10, 15, 20, 25, 30, 35, 40, 45, and I'll agree with you that the lowest common multiple is 45. Okay? Now, we want to turn 4/9 into a fraction with 45 as the denominator, correct? And we want to turn 3/5 into a fraction where the denominator is 45. Now, where I lost you a little bit is, I think if I understood you correctly, you said that the new fraction is going to be 4/45 and 3/45. Is that what you told me?
Is that wrong? Is that wrong?
Okay. How do you get from 9 to 45?
You times it by 5.
Okay. Big rule. If you don't remember anything else from today, okay? Whatever you do to the denominator, you have to do to the numerator.
Okay.
So if I multiply the denominator times 5, what do I have to do with the numerator?
Times it by 5.
Yes. So my new fraction is what?
20/45, not 4/45.
Exactly. And the same thing in here. What do I multiply 5 times to get to 45?
9.
Okay. And what do I have to do on the top?
Multiply it by 9, and you'll get 27/45.
Exactly. Okay. Now we're almost there. Now we have to do what? What's our next step?
We have to add, since the denominators are the same now, we have to add 20 plus 27, and that'll give us 47/45.
Right. That's a plus over 45. Okay. So now we have 47/45. Okay. I wasn't really planning on this happening, but it did.
I know.
Okay, so what do you know about a fraction where the numerator is greater than the denominator?
It is an improper fraction.
It's an improper fraction, exactly. So can you turn this into a mixed number?
Yes.
Okay.
Do you, is, do you divide 45 by 47?
Well, you think to yourself, no, what you think to yourself is how many holes are there? In other words, how many 45s are there in 47? Because we're trying to make holes. Okay?
Okay.
So how many
So
45s would there be in 47?
it's 1.
And what would be left over?
2 over 45?
Exactly, 2/45. Okay, so now we need to still determine whether this is lowest terms. So
Okay.
the whole number, we're leaving alone, right?
Okay.
Okay, but now we have to figure out whether the fraction part of it is lowest terms. So is there anything that you can divide into 2?
No, because 45 is an odd number.
Exactly, exactly. So even without writing out the greatest common factors, you know that the factors of 2 are 1 and 2, and the factors of 45 do not have a 2 as one of the factors, right? So this is,
Wow. And that's the answer?
mm-hmm,
Wow. That's a
yep,
lot for one answer.
I know, it's a lot of work. There are a lot of steps in math, and if you miss one step, right?
You get
Okay,
the whole answer wrong.
exactly, exactly. Once in a great while, on a certain test, they'll like look at your steps and they'll give you, they'll give you credit for partial steps. But,
Okay.
especially when it's multiple choice, they're not going to give you that.
Okay.
They're not going to give you that. So I think, we have time for
Okay.
all right, let me get another one. Let me see if I can come up with one that's not going to be a mixed number. But no guarantees. I'm making these up in my head here. Okay, let's see. Let's see. All right, let's try. Oh, what the heck? Okay, we're going to start with smaller numbers. Let's do 2 7 and 1 8.
So what I do, someone taught me to multiply. If you multiply the denominators, then you'll find your new denominator.
Absolutely. If you multiply them, then you know that you have a multiple of both of them, right?
Yes.
So the difference is, this is the difference, okay? The difference is that you may end up with way bigger numbers than you
Yeah.
need, okay? But
Right.
there's no problem with doing it. And when you're using numbers that are sort of smaller to begin with, it might not be a bad idea. So if we want to do that, let's go ahead and do it, okay? So what's
Okay.
our denominator going to be then?
It will be 56.
Good, okay. So I want to change 2 7ths into something over 56, and I want to change 1/8 into something over 56. Okay, so what we've done here, Talisha, just to remember, is we sort of skipped the step of lowest common multiple. Now, it's possible that 56 would have been our lowest common multiple anyway, but we just didn't write it all out, okay?
Okay.
So, and that's fine. We'll have a common denominator, okay? And that's fine to do. Okay? So now I want you to figure out what our new fractions are. So I'll give you a minute to decide what our new fractions are.
The new fractions is 16 over 56
Good?
plus 7 over
Good.
56.
Okay, and you did exactly right. You, in essence, did this, okay? And you did this, right? Okay, so our new
Yes.
problem is 1656 plus 756. Okay, and what do we have?
We have 23 over 56.
We do. Okay. All right. Now, the next step is to decide whether this can be simplified put into lower terms. So the question is there a common factor in 23 and 56?
I don't know. I think no, because 23 is an odd number, and 23 is an odd number, and I don't think there's a factor that goes into 56 and 23 except
Okay.
one.
Except one, you're right. So 23 actually is what we call a prime number, which means its factors are only one in itself. The only thing you can multiply to get 23 is 1 times 23. So the only way that we could reduce this is if 23 was a factor of 56. But 23 times 2
It's
is 46.
46.
And if we
Right.
multiply by 3, it's going to be, bigger than 56. So you are right. That is the simplest, the lowest.
Okay.
All right. So
That was good.
all right. So when we started, you had some confusion between greatest common factor and lowest common multiple and how it applies to equivalent fractions, right?
Yes.
So again, lowest common multiple is when you write the number, okay, and say I had a 4, 8, 12, 16. This would be the lowest common multiple. That's helpful in forming, raising the fraction, okay, for a new denominator. Okay, that's when we use lowest common multiple. Or as you said, you could always just multiply the two denominators times itself, and you will have a common denominator. Okay? Sometimes it'll just end up with bigger numbers than you needed to have.
Okay.
Okay? So for instance, if you had a fraction 3/15 and 2/5, okay, and you were adding these two, if I multiplied 5 times 15 and used that way to get a common denominator, okay, I would get 75. The truth of the matter is 15 can be the common denominator.
Right. Right.
Okay, so that's why sometimes you want to do least common multiple, but it would have been fine if we got 75. You would have then just had to do a lot more reducing at the end. Okay?
Okay.
All right. And then the other thing that we did, I'm trying to find a blank piece of paper here. Okay. The other thing we did was greatest common factor. And greatest common factor is when you take the number and you simplify. Okay, and say it was 8, okay, and that would have been 1 and 8 and 2 and 4, and the greatest common factor is 4, okay? So I had the fraction 8/12. I know I can divide by 4
To reduce it.
to reduce it, okay? So that's where least common multiple and greatest common factor come in.
Okay. That now, no one never explained it to me so easy. So easy. I can never forget that.
I hope it's helpful. And again, if you want to ever, look for divisibility rules that are also like a good way to try to, to simplify a fraction, just look it up online and you'll get those. Okay.
Okay.
All right.
That was awesome.
Oh, I'm so glad. I'm so glad. I hope it was helpful. And good luck. I can't believe you're done with 3 out of 4 of them already. That's amazing. Just amazing.
Thank you.
All right, Talisha, have a good day. Take care. Bye-bye.
Yes, thank you. Bye. Wow.
Bye-bye.
She did that amazing.
Okay, I guess I should finish this up. So that was our lesson on reducing and raising fractions, forming equivalent fractions. And thanks to Tylisha, we also got into the concept of greatest common factor and lowest common multiple. That's it for today. Hope everybody has a good day. Take care. Bye-bye.